Okay, so you guys know that I'm not going to be here on for a couple days. So for lesson 3 and 4, instead of having my sub teach you, I'm going to try and kind of do this flipped classroom thing. So what I need you to do is make sure you have your lesson 2 notes out, because there was a question on there that we didn't go over, and it was factoring by synthetic division. So we're going to go ahead and start with that. This is lesson 3. Lesson 3 and 4 will kind of go together, but in order to show some of the stuff for lesson 3, I need to make sure we do synthetic division. So lesson 4 will review synthetic division and get into long division a little bit further. So lesson 3 is finding all zeros. And this is really just a continuation of what we've already done in Unit 2, a little bit in Unit 3, because we found zeros for quadratics. So now we're doing finding zeros for polynomials, which means basically you're going to have more than 2 answers probably. So if you look at your polynomial, especially this one here where you have 2x cubed minus 7x squared minus x plus 6. If something's not factorable, synthetic and long division is another way to go about solving. So you're going to see problems like this one where you're given a 0, which means your factor came from x plus, or not plus, x minus 1. So if you set this equal to 0, it'd be x minus 1. So your factor is x minus 1. So x minus 1 times some other polynomial is going to yield the 2x cubed minus 7x squared minus x plus 6. So synthetic division can be relatively easy as long as we know what we're doing. So the steps are here, write in standard form, powers in decreasing order, don't skip powers. So what you do is you write down the coefficients of all the powers. So I have 2, -7, -1, and 6. And then on the outside, you write your 0. So if you're given a factor, whereas where I just said our factor was x minus 1, you put your 0 on the outside. So it's not -1 on the outside, it's going to be +1. And your very first step is to drop down that first coefficient. Okay? On the inside, you're going to add. On the outside, you're going to multiply. So I'm going to multiply 1 times 2, and that goes here. Now I'm going to add down. So it's -7 plus 2, which is -5. Now I'm taking 1 times -5, -5, -1 times, or plus -5. It's going to be -6, multiply on the outside, and I get 0. That 0 here tells us that x equals 1 is a 0. It basically confirms it for us. If we have any other value on the outside there, that's going to be a remainder. So I'll talk about that in a little bit. Actually, probably that'll be more of lesson 4 than 3, so it'll be in the next video. So now what we've just done is actually divided out. What you just did was you took 2x cubed minus 7x squared minus x plus 6, and you divided it by x minus 1. So that means we should have x minus 1 times something is equal to 2x cubed minus 7x squared minus x plus 6. And what that 2, -5, -6 is basically that polynomial that is your quotient. So your divisor was x minus 1. The polynomial that you're dividing out was the original. And what you're left with is 2x squared minus 5x minus 6. Okay? So on your own, I'm going to ask you that you pause the video, and I want you just to multiply. I want you to multiply the 2x squared minus 5x minus 6 times x minus 1, and I want you to think about what you're going to get before you multiply it, and then you should notice something when you do multiply. Okay, after you've multiplied, you should get what you see in blue, the 2x cubed minus 7x squared minus x plus 6. This is why I hate FOIL. You'll remember my rant from earlier on, because FOIL doesn't allow you to multiply a trinomial times a binomial. Even though it is the distributive property, if you know FOIL as the distributive property, I'm totally fine with it. But a lot of times we forget what the distributive property actually is. So I wrote that out for you all in blue. And when you simplify, you get your original expression, 2x cubed minus 7x squared minus x plus 6. So that is synthetic division. I want you to go ahead and again press pause and go ahead and do number 2, the x cubed minus 2x plus 4. You need to make sure you recognize that there is a power that is skipped. So over here in our directions, it says don't skip powers. So I want you to think about what the coefficient of the x squared term would be in number 2. So go ahead and pause. My work will be up when you press play, so you can see all of the step by step. Okay, so when you do synthetic division with number 2, this is what you should get, and your quotient should be x squared minus 2x plus 2. Okay? If you have any questions on this, I would actually just stop and restart the video and try them again, or try them again and then look back over your work to make sure you did it correctly. Okay, now what I want you to do is just get out a piece of paper. If you have your notebooks, you're just going to label this as lesson 3 if you haven't already. We're going to go over a couple different things. We've basically done finding all zeros throughout the year. Now we're just kind of doing it with polynomials, which is actually a little bit more fun. Last class in lesson 2, you learned different techniques. Factoring out of the GCF still applies. If there's a difference of squares, you still want to do it. So that example on lesson 2 where you saw 4x squared minus 81, you're going to see 4x, you can see 4x cubed minus 81, which you've actually already seen. We just did that as factoring instead of solving. Sum or difference of cubes, that is going to be a pattern you're going to want to memorize. I'll talk to you about that in lesson 2, so make sure you're memorizing that. Factoring by grouping and quadratic trinomials, the reason I showed you how to factor by grouping with trinomials back in Unit 2 was because of this, because you're going to now see 4-term polynomials. You're going to see 5 terms, 6 terms, so that's going to, factoring by grouping is going to be pretty crucial to finding all your solutions. Okay, so I want you to make sure you have a blank page in front of you, okay? So what we're going to do is just solve for x. Okay, first problem I want you to do is going to be 2x to the 6th minus 2x to the 4th minus 40x squared. Okay, so the first thing I hope you recognize is that we have a GCF of 2x squared. So you always want to factor out that GCF. It makes your life a lot easier. Okay, so then x to the 4th minus x squared minus 20 is what we have left over. Okay, now that second term is just a trinomial that we've seen and we've dealt with before. The only difference is that it has a degree of 4. Okay, also, I guess I should say, before we even begin when we're dealing with polynomials, we should recognize that the degree is 6, which should give you an indicator of that we're going to have 6 solutions. That does not tell us the nature of those solutions. We could have 6 real solutions, which means we would see all 6 on a graph. We could have 4 real solutions and 2 imaginary. We could have 2 real solutions and 4 imaginary. Remember, your imaginary solutions always come in conjugates, so if you end up with a negative I and you don't end up with positive I, you did something wrong, so make sure you check on that. Okay, this trinomial is factorable. We factor it the exact same way. We're going to take are factors of negative 20 and break up that negative x squared. So the factors of negative 20 that add to negative 1 will be negative 5x squared plus 4x squared minus 20. Okay, factor by grouping. Out of the first two terms, I can take out an x squared. Oops, I'm left with x squared minus 5. Okay, out of the second two terms, I can take out positive 4. And I should have x squared minus 5 left over. So my factors are x squared plus 4 and x squared minus 5. And now remember that this should still drop down. Okay, so my expression completely factored is 2x squared times x squared plus 4 times x squared minus 5. Okay, at this point, we are factored as far as we can go, so we're going to set all of those factors equal to 0. 2x squared equals 0. That one's easy. Hopefully we know by now that it's just going to be x equals 0. We have x squared plus 4 equals 0, and x squared minus 5 equals 0. Okay, after that, subtract 4. Take the square root. Remember, you take the square root across an equation and you get plus or minus. Okay, I'm taking the square root of negative 4, which means I should have an I value. Okay, I'm showing more steps than I need to, but that's mostly because I'm doing this on a video and not talking to you guys as you're sitting right in front of me. So now I take the square root of 4, which is 2. So now I have 3 of my solutions. X equals 0, x equals plus or minus 2i. Okay, and the last one, x squared equals 5, so x equals plus or minus root 5. Now if you notice, we actually only have 5 of those solutions written down, not all 6. So we need to go back and look at this. The 2x squared means that the x equals 0 is a double root. Okay, now graphically that means that the solution x equals 0 bounces. So if I were just to draw a quick sketch of this graph, now remember, I don't need you to worry about maximum and minimums unless it is a calculator question. I will never ask you for a maximum and minimum without the calculator. That is a calculus concept that we are not going to worry about right now. Okay, for the graph, plus or minus 2i is not going to show up. So you need to be thinking, okay, there's going to be 3 solutions that are going to show up on my graph. One of those is a double root, meaning I'm going to have 4 solutions total that I could actually see. Okay, you need to think about what the value of square root of 5 is. The square root of 5 is between which 2 perfect squares, so you should be thinking, okay, 2 and 3. So I'm going to have a solution that shows up about here, negative root 5, positive root 5, and 0, 0. Okay, another thing I need to recognize is my leading coefficient is positive. So I should be going up, and then I have root 6, and the degree of 6, which is telling me that I'm going to go in both directions. So positive, leading coefficient, and an even degree. That is a terrible drawing. Okay, the minimums here, not really worried about. Okay, they'd probably be even. But I'm not worried about those. What you should also understand is that the number of turning points, or maximum number of turning points, would be the degree minus 1. Okay? So we could be thinking about 5 turning points. Okay? So we have 1, 2, 3, but 2 of our solutions are imaginary, so that's why we only have 3 and not 5. Okay? Okay, the next thing we're going to talk about is the rational root theorem. There's a kind of a confusing definition in your textbook. I'm going to read you what the actual rational root theorem is. No, I'm not. It's really confusing. You can go into your book and look at it. It's on page 312. Okay, so that's the definition if you want to write it down. But basically what it tells you is that, let's take that last example that we just did. Okay, so if I have a polynomial, 2x to the 6th minus 2x to the 4th minus 40x squared. Basically what your rational root theorem is takes your constant, okay, and divides it by your leading coefficients. And it's not just those two values, negative 40 and 2. It's the factors of negative 40. So you've got 1, 2, 20, a lot more than that, okay, divided by all of your factors. And all of these are plus or minus. Divided by all of your factors of your leading coefficient. So in your homework key, you're going to see a lot of these. What this allows you to do is test. And what you do at this point is you could basically start with, okay, maybe x equals 1. Okay? And at that point, you would take 1, and you could substitute that in. So we could substitute 1 in. And see if it equals 0. Well, we just solved this one, and 1 was not one of our solutions, so that is not true. But it is a possible rational root. So rational, okay, means that we're not going to have, that's not going to be the square root answers, but it could give us the rational solutions. It doesn't really narrow it down, so what you would do, or what I would allow you to do, is use a calculator. So I'm going to give you one more. Not one more, there's like 4 problems that I want to go over. But I think after this you'll be able to do a few of them on your own. So this next one that I want you to do, we'll do together. 0 equals x to the 4th plus 7x cubed minus x squared minus 67x minus 60. Okay, so the rational root theorem gives me the factors of, so it's basically P over Q, where P is your leading, or your constant, over your leading coefficient, which is 1. So it's your factors of negative 60 divided by factors of 1. So all of those are possible solutions. Okay, that takes a lot of time to test. So what I want you to do right now is go into your calculator and type in your y equals screen this equation: the x to the 4th plus 7x cubed minus x squared minus 67x minus 60. So pause the video and make sure you get your calculator and type that into your y equals screen. Okay, as you put this into your y equals screen, that's the first screenshot you should see. What you need to make sure you notice is that your plots are not highlighted. If they are, you have to go back into that y equals screen and turn them off. You just scroll up and press enter on the plots. If you were to graph this and you pressed graph, if they were highlighted, you probably get the invalid dimensions. So you want to make sure you have those off. once you hit graph, this is what your graph looks like in a 10 by 10 coordinate plane. We can easily see what our zeros are. We have a 0 right here, here, and 2 of them right here. Okay, so that's 4 solutions, which means we have 4 real solutions, which means no imaginary, so we have just 4 real solutions. Okay, and 3 turning points, because they're all real solutions. We have a turning point here, there's going to be a turning point up here, and down here. That graph is going to go up, back down, back up. Okay, we're going up and up based off of our leading coefficient and degree. Okay, so now this is kind of a different example than I would probably give you, because you can see all of the factors or all of the zeros from your graph. So that I'm giving this to you just so we can do synthetic division easier. So we do know what I would give you is a calculator, and you would graph it, okay, and then you would pick a solution, and you'd have to do all of your work based off of that solution. So if I'm saying x equals 3, what you're going to do now, again, remember that means the factor is x minus, oh my goodness, is x minus 3. Okay, so finding all solutions, we're going to take our 0 and do synthetic division. Okay, where our coefficients of every term, 1, 7, -1, -67, and -60. Okay, now right here, because that is a 0, we should end up with 0. Okay, so first step, drop down your 1. 3 times 1 is 3. 7 plus 3 is 10. 10 times 3, 30. We get 29. 87. 20. 60, and we got 0. So right now, we can take x minus 3 times x cubed plus 10x squared plus 29x plus 30, and that will yield our original. Okay, but we're not done yet. What we can do is synthetic division again with another one of our zeros. So another one of our zeros is -1. Okay, so again, drop down the 1. Let's use a different color. Drop down the 1. -1 times 1, 1. -1. 10 minus 1 is 9. -9. 20. -20. 0. Okay, so now breaking it down further, we've now gone x minus 3 times x plus 1 times x squared plus 9x plus 20. Now we can do synthetic division again with the other 2 zeros that we have. Okay, or hopefully we notice that x squared plus 9x plus 20 is factorable. X minus 3 times x plus 1 times x plus 5 times x plus 4. Okay, so this equals to 0, and it's fully factored. So if it asks you to factor completely, this is what you would give. And you have to use synthetic division to get there. Okay? And then if it asks you for all your solutions, you'd set each of these equal to 0, and we'd get x equals 3, -1, -5, -4. Okay? I want you to go ahead and try and graph that. Okay, I know we already graphed it on the calculator, but now that you have your zeros, you know your leading coefficient, and you have your degree, go ahead and try and graph that on your own. Okay, that should be relatively what your graph might look like based off of the leading coefficient degree. y-intercept. That's very important that a lot of my students forget. So if you're asked to graph like this, you don't need to worry about maximums and minimums. Just worry about your zeros and your y-intercepts. Okay? All right. Now on Blackboard, there go to the notes for today. They're handwritten notes. Okay. There are 2 other questions, I believe. So I want you to go ahead and try those. Check your answers. The graphs for all of the graphs are on the last page of the notes. Okay? All right, that's lesson 3. Thanks, guys.